So today our problem statement is given two boundaries, let's say set by left and right. You have to find two prime numbers, say num1 and num2 between these two boundaries such that the difference, that is num2 minus num1, is the minimum amongst all the pairs satisfying this condition. And it has to return a positive integer array, that is num1 comma num2. In case there are multiple pairs which satisfy this condition, then you have to return the one with the smallest num1 value. If no such numbers exist, then it has to return -1, -1. Let us try to understand this problem with an example. Consider you have given the boundaries like left is 10, right is 19. Now the output is 11, 13. How? Assuming that 10 and 19 are given to you. What are the prime numbers we have? We have 11, 13, 17 and 19. Now if I find the closest gap between any pair, let's say I find the gap between 11 and 13, so I'll get 13 minus 11, which is 2. If I find the gap between 13 and 17, I'll find 17 minus 13, that is 4. And between 17 and 19, that is 19 minus 17, is going to be 2. So the minimum, the closest gap we have is 2, which can be achieved by taking the pair like 11, 13 or 17, 19. But out of these two pairs, since 11 is smaller than the 17, hence we will return the first pair, as a result of which we got 11 and 13. Now another example, let's say the boundaries set are 4 and 6. Now here we observe that between 4 and 6, there is only one prime number exists. Hence the condition cannot be satisfied. I cannot find the second number with which it can be paired. Hence the outcome has to be -1, -1. Now let's understand the logic for this. We have considered one function, that is underscore prime. For example, this function that we have taken is the one which is going to verify whether the number is prime or not. If the number is prime, it is going to return true. Otherwise, it is going to return false. Now, later on, we have taken another function, that is your closest prime, where I am taking the two boundaries that have been given to me, that is left and right. And here I am going to take some variable which is going to store infinity at the beginning, the minimum difference, and the result we have initialized with -1, -1. Now this for loop is responsible to find out the numbers between the range that is given, between left and right, whatever numbers are available, that it will be giving one after another. Now, every time I will check whether the num1 is a prime number or not. Because when I call isPrime function on num1, I am going to find out whether num1 is a prime number or not. If it is a prime number, then only I am going to check. I am going to take all the remaining numbers starting from num1 plus 1 till the right plus 1. So, now num2 also I will verify if it is prime or not by calling the same function that we have defined here. Now if num1 is prime, num2 is also prime, then only I will check the difference, and I'll check whether the difference between these two, is it less than what we have taken already initially. If that is the case, then I will set this result or update this result array with the values of num1 and num2. So by the end of this entire function, what I'll be receiving is the value of the result, which is going to give me the final outcome, which can be the difference, whose difference is going to be minimum, or it may return -1, -1 if no such prime numbers are available in it. Let's understand in detail how this problem can be solved. So to start with, we have called this closest primes function, which is taking two values, say 10 and 20. So which are of course going to be the values of left and right, which is 10 and 20. So the function closest underscore primes has been called with these two values, that is left and right. So now when we reach this function, the left takes 10 and the right takes 20. So when we get into the function body, so very first line we have taken like mean underscore difference equal to set to infinity. Okay. Now at the same time we also took this result which is holding -1 -1. So now when I start this outer for loop, where we have written like num1 is in range of left comma right plus 1. So as the left value is 10, right value is 20, so 21. So between 10 and 21 means we always understand that range function will exclude the last one. I mean the values will start from 10, it will goes up to 20. So num1 will start with 10 followed by 11, 12, 13 up to 20 it is going to consider. Okay. Now, first time the value for the first iteration when I start the outer loop, this is the outer loop, right? So we are going to start with the num1 value 10. Now, before I can proceed for this inner loop, what is the first thing we are going to verify is whether this num1 is a prime or not. Now, I am going to call this is prime function which I have defined to find out whether this value or this num1 value is prime or not. So, what is the num1 value right now? 10. So, 10, is it prime number? No. So, as the function is being called, it is going to return towards the end what? False. Because this num1 is holding 10 which is false. So as a result, this inner loop is not going to execute right now. It is going to go down, go up to the next iteration, that is your iteration 2. For which, what is the num value is going to be? 11. Now when I am going to apply this is prime on this 11, so I am going to get true because 11 is a prime number. Now because this 11 is a prime number, this inner loop is now going to execute. So as a result, the num2 will start from num1 plus 1. What is the num1 presently? 11. So 11 plus 1, 12. And right plus 1 means that is 20 plus 1, 21. Okay. So this num2 will now start from 12 and goes up to, excluding this means up to 20. So now first time I will take num2 as 12 and I am going to verify whether it is a prime number. So once again this prime number function is called upon 12 and it returns me false because 12 is not a prime number. Now next we go on num2 as 13. Next value of num2 will be 13. So once again when I check the is prime function on 13, so I found this as true because it is a prime number. So we found 11 already one prime number. And the next prime number is num2 which is 13. So now what we are checking is we are checking the difference between num2 and num1. So num2 is holding 13 and num1 is holding 11. So 13 minus 11 is 2. 2 less than the minimum difference which I have taken as infinity. So of course 2 is less than infinity. So it is true, right? So as a result the minimum difference is updated to 13 minus 11, that is 2. And your result, okay, and result is set to num1 comma num2. What is num1 here? 11. What is num2 here? 13. So this is the latest update that we have made to result. Now going ahead with the next iteration for num2. So once your 13 is done, next I check with 14. So it is not a prime number, so I am going to return false. For the next iteration of num2, it is 15. So once again, it is not a prime number, written false. For 16 also, we are going to get false. Now, when num2 becomes 17, this is prime is going to return true because it is a prime number. Now, once again, we will check whether this difference num2 minus num1. So what is num2 now? 17. What is num1 as of now? That is 11. So 17 minus 11 is 6, less than minimum difference. What is the latest minimum difference? It is 2. So 6 less than 2 is false. Hence, I will not be updating either of them because this condition has failed. Moving on to the next num2 value, which is 18. So 18 is not a prime number, hence I am going to get false out of it. And next time we'll take num2 as 19. So 19 is once again a prime number, so I am going to get true out of this. Once again we will verify this difference, like num2 minus num1. What is the num2 value as of now? 19. What is num1? It is still 11, right? So 19 minus 11 is 8. 8 less than the minimum difference as of now is what? 2 only. So this is resulting false. So nothing is going to be updated here. Now when we go for the last odd time, that is num2 becomes 20. So 20 is not a prime number, hence it returns false. So now the inner loop has reached the last value, right? 12, 21 means it is going to go up to 20. So the inner loop is ending for the second iteration. Now when we go to the third iteration, when we go out and check for the num1. So num1 value next time, earlier it was 11, now it is going to be 12. So when I apply this is prime function on 12, I am going to get it false. So now when we take the next iteration where the num1 is going to be 13, so this is prime function is going to return true. As a result, I will be getting inside this inner loop where num2 will start work again from num1 plus 1, that is 13 plus 1, 14, and goes up to what? 21 once again. Now what is the num2 value to start with? 14. So 14, I'll check is it a prime number by applying this function. So what I'm going to get is, it is false. Moving on to the next num2 value, which is 15. That also gets me, is prime will get me false. Num2 is 16, again will get is prime false. Okay, hence for 14, 15, 16, these two statements will never execute. Now when num2 becomes 17, so 17 is a prime number. So now I will be checking num2 minus num1. What is num2 as of now? 17. What is num1? 13. So 17 minus 13 is how much? 4. 4 less than, what is the minimum difference we had earlier? 2. So 4 less than 2 is what? False. Okay, so no updations are being done to this. Moving on to the num2, next value is 18. So once again it is not a prime number, so I am going to get false for that. And for 19 once again we will get the prime function returning true. Now we will calculate this num2 minus num1. What is num2 holding? 19. What is num1 holding? 13. So 19 minus 13 is 6 and less than 2. What is 2? The minimum difference as of now. So 6 less than 2 is false again. So we will not have any updates here. Next, when num2 becomes 20, when I call this is prime, I am going to get this false. So now we have come to the end of this inner loop. So now we'll move on to the next iteration, which is iteration 5, for which the value of num1 becomes 14. So when I check is prime on 14, it is false, which means this inner loop will not at all execute because the outer loop is false. Now, iteration 6, the num1 has become 15, right? So when I apply is prime function on 15, okay, so it is going to give me false, hence we will not get into the loop, second loop. Similarly for num1 value 16, for the next iteration, it is also going to get me false. Next, when we go to the iteration 8, where the num1 is holding 17, so 17 is a prime number, right? So hence this is prime will return true. Because it is returning true, so this entire statements may start executing. Now as a result of which this num1 is 17 now. 17 plus 1, this is 18. 18 and this is 21. So my num2 will start with 18, goes up to 20. So first time when the num2 is 18, if I check is prime of, this is 18, is prime of 18. So it is going to give me false. Next time when it is 19, so is prime of 19 is true. So hence the difference we will calculate first. Num2 minus num1. What is num2? 19. What is num1? 17. So 19 minus 17 is 2. So 2 less than 2, because already the minimum difference is holding 2. So 2 less than 2 is false. Hence, we will not update minimum difference or result. Now next iteration, num2 becomes 20. So 20 is prime function is going to return false. So the inner loop is now over. We'll move out and iteration 9, for which the num1 is 18. So when num1 is 18, is prime is going to return false because it is not a prime number. Okay. Hence, we will not be able to check this inner loop. Now, when iteration 10, the number 1, I mean the num1 is your 19. And when I call this is prime on num1, that is 19, it is true. So once we get into this inner for loop, num2 will start with 19 plus 1 means 20. And this is also 21 means 20 to 20 only once. Okay. So num2 will be 20. So when I check is prime on 20, I am going to get false. Hence, there is a end of this inner loop. And we have also reached the end of your outer loop here. Now, by the end of this entire loops, okay, what we are going to return towards the end is result, which is presently holding what? 11, 13. So, which is the closest method or closest two prime numbers that we have got as a boundary set to left equal to 10, right equal to 20. So let's run this program. So we have taken the same left, right, 10, 20. Okay. So when I run this program, I'm going to get the output as 11 and 13. If at all we change the input, that left and right, suppose I'm giving it's 4 and 6. So now when I'm going to run this, I'm going to get -1 because there is no two prime numbers whose difference can be calculated. Thank you.